Hello everyone, welcome to this new video. So in this today's video, we'll be solving the problem painting the fence. And it's a medium level question and it's a problem of the day on Geeks for Geeks. The company tags haven't been mentioned, but I see that this question has been asked by Bajaj Electricals and the topic tags of this question are arrays dynamic programming. Fine. So let us go to the question now. So given a fence with n posts and k colors, n posts in the sense n sections in the whole fence. Okay. So there might be a whole fence. So fence in the sense a rectangular, consecutive arrangement of rectangular sections. You can assume it like that. And there are n sections in it and k colors. So there's an option for you with k colors. You are available with k colors. Okay. So find out the number of ways of painting the fence. Okay. Painting the fence in the sense you need to paint all the sections so that not more than two consecutive posts have the same color. So it's pretty evident they're asking you to paint in such a way that not more than two sections consecutive section will be painted with the same color. So if you're painting the first and second section with red color, the third section should be painted with different color, because if you paint the third section with also the same color, then all the three would be having the same color, right? The consecutively three. So that's not feasible, that's not allowed. Either you can paint the first second to be red and then leave the third one with some other color and then fourth fifth with red. You can maintain that, that's not an issue. Okay. So you can have many pairs of two sections to be of the similar color, consecutive section. That's completely fine. So since the answer can be large, written it modulo 10 power 9 plus 7. So this is one of the example. We'll see that in brief. And the expected time complexity is O of n and space is O of n. So we are going to solve this in time complexity O of n and space is 1, O of 1. Okay, we'll be solving this in constant space. So, and the constraints are n goes up to 5000, k goes up to 100. To be honest, this problem is pretty similar to yesterday's problem, almost the same. It's just that the conditions are different, the environment is different of the problem, but still the logic remains the same, to be honest. So let us see how it goes. So going through this example one, this is example one, fine. So example one as n equal to 3, n equal to 3 in the sense 3 sections, first section, second section, third section, and k equal to 2 in the sense 2 colors. What are they? Green and white. Okay, green and white, these are the two colors that are available to us. So how many possibilities are there? If you can just see, there are 6 possibilities, total of 6 possibilities. Fine. So there are total of 6 possibilities. So what are the 6 possibilities? Either you color first, okay, I'll be using a red ink. Either you colored first two sections with green, okay, first two sections with green and third section to be white, or first two sections with white and the last section to be green. We are not coloring this to be green. Why? Because if we do that, three sections consecutively, three sections are with the same color, and that's not allowed. So that is the reason first two you can use a same color and the third one to be a different color. Similarly, in this case, second case, first two are white and third one is green. Here green white green, okay, and green white white. Here white green white, here white green green. Okay, so is there any other possibility? No. Start with green in the first box. Either you can choose the next box to be a different color like white or green. Again, if you have, you can choose the option to be, now once you have chosen green in the second box, the third box must be white. Okay, so that is done, and the second box can be if the second box is white, the third box can be W, or it can be green, or so green white green, yeah, these two. So these three possibilities if you start with green, and other three possibilities when you start with W. Okay, so totally 6 possibilities in complete. Okay, so I hope you people understood how did we come to this conclusion, like why there are only 6. Fine. So that is output is about how many number of possibilities that are there, so that you maintain this thing that only two sections must be having, consecutive section must be having the same color, not the third section. Fine. So what is the approach? How do we frame this approach? Before I begin explaining this, I've actually gone through this painting fence algorithm in the month of August or September. I do not remember it correctly. So I take that intuition and I, like, that's the whole approach, that's the only, that algorithm is primarily for these type of questions. So I understood algorithm there. So basically there are various possibilities, right? Like as said, when I was solving this particular question, I started by taking green here, and then I'm choosing to the second box to be green or white. And if I choose the green in the second box, I'll not be able to choose green again in the third box, because if I do that, green 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 will be 3 sections in one. So we need to keep checking that, and then we need to move forward, and like lot of possibilities are there, lot of possibilities. But we need to solve this question in O of n, right? If you see the constraints, time complexity expectation, they asked us to solve this in O of n, and it is the only feasible because n goes up to 1000, I guess, I'm not sure. Yeah, n goes up to where is this? Yeah, n goes up to 5000. So you cannot be putting like because you have you're working on two conditions, so you'll not be using some algorithm that takes time complexity like O of 2 power n. That's not going to be feasible, right? It's not exponential cannot work here. So you need to look out for such an intuition or such a breaking point, okay, or such a start point, so that you build up your intuition from there. You frame a relationship between the work that you're going to do right now and the work that you're going to do later. That's the main observation that you need to have, okay, because right now we have no clue. It's like just like the bare trial and error method, starting putting the first box with green and then next box with green or white and then other things, because just because we have k equal to 2, now we are only exploring two options. We might be having k 3 4 5 lot of colors. So how are we going to do? So in these type of problems, it's always better to start with a base point, okay, as assume as if you're only having the one box, and then develop the intuition what you'll be doing it for when you'll be having two sections, three sections, four sections. What is the relationship that you're having with the present work and the future work? So if you decode that relationship, if you decode that recurrence relationship, then we are done, right? So that's what we'll be doing right now. So take let us assume the thing that I'm trying to tell is, let us assume there's only one section right now, okay. This is the only fence that we have. I mean, fence in the sense lot of sections, and now I'm saying I have only one section, okay. And the possibilities are, and I've been giving you that the total number of colors, okay, I'll be using a different thing here, maybe, yeah, yellow is there, yeah. So I'm telling you that there are four different colors. What are they? For k equal to 4, I'm telling you the different colors that are available for you is blue, red, and green and yellow, okay. Let us assume I'm saying that there are four different colors to you and there's only one section now. So how many different ways you can color this? How many different ways can you color this? I can color this in four different ways, okay. So the different ways is four, okay. Different ways is four. And how many? Same in the sense, is there anything that there another section to compare with this first section? I'm telling you there's only one section right now, so there's any other section to compare? There's no other section to compare. So right now the same has no existence, like the word same. If I have another section, then I would say what if I color both of them as same, but there's no other section to compare, right? So I can just put this same to be 0 as of now. Let us assume now I'm joining another section, okay. I'm joining another section. I'm joining another section here, okay. Now what are the possibilities? Now if you say, now if you're trying to like on this particular fence, okay, on this particular section, sorry, on this particular section, there are two choices. Either you can paint it differently from the first choice or from the first section, or you can paint the same thing that you have painted on the first section, okay. So what are the two things? Same and different. What do I mean by when I say same? Same in the sense I'm painting the same color that I did for the first section. Let us assume out of the four different options, I have painted the first section to be blue, okay. I painted the first section to be blue. And if I'm saying that I paint the same color that I painted for this first one to the second one as well, so I'll be even painting the same thing for the second one as well. But how many choices are there? So if I just sorry, I'll just put it as full screen. If I put the first one to be blue, second one will also be blue. If I put the first one to be red, second one will also be red. If I put the first one to be green, second one will also be green. If I put the first one to be yellow, second one will also be yellow, right? So whatever the color that I'm putting to the first one, the same thing I'll be putting to the second one as well. So I mean, whatever the different choices I have to the first one, the same I'll be replicating here, okay. So same is basically nothing but different of the previous what I had, right? Different of previous what I had. In other words, if I'm trying to paint the same thing to this first one, okay, so what are the available choices that I have for the previous one, like the different choices? I'll be putting the same thing here. I'll be putting the same thing, different. So when I extend this to a third section, you'll understand it better. And what if I'm trying to paint it differently? What if I'm trying to paint it differently? For first one, I had k choices, B, R, G, Y. So what would be the second one? Different, if I mean different. So if I paint it as blue, I can paint it as yellow, or I can paint it as red, or I can paint it as green, okay. I have three choices, isn't it? I have three choices. If I'm painting this first one as blue, I have three choices. What is that? K minus 1, because one choice I'm already using, so the other choices left are k minus 1. So that is what I'm going to do. So how many will be there? So that is k minus 1 times total of previous. So what do I mean by total? So here in this case, total is 4 plus 0, that is equal to 4. Total is 4 plus 0 equal to 4, right? So the same thing, whatever the total number of possibilities are there, I'll be multiplying that with k minus 1. I'll explain it very briefly. You'll get a very brief understanding when I put the third section. You'll definitely understand. So right now, different equal to k minus 1 into total previous. What do I mean by that? What are the possibilities? So let us assume I'm painting the first one with blue. So if I'm painting the first one with blue, the second one would be red. If I'm painting the first one with blue, I will be getting the second one can be green. And if I'm painting the first one with blue, the second one can be white, yellow. So BR, BG, BY, three options. And what are the other options? If I'm painting the first one with red, red. So similarly I can get B, RG, RY. And if I'm painting the first one with green, I can get GB, GR, GY. And what if I'm painting the first one with yellow? I can get YB, YR, YG. Okay, so these are how many possibilities in total? Totally 3 plus 3 plus 3 plus 3, 12 of 12. And in the same case, how many are there? 4. Totally 16. So same is actually equal to 4, and this is 16. Okay, so this is basically 3 times. Okay, sorry, this is not 16, right? This is 12. So this is 12, 3 plus 3 plus 8. So this is basically 3 times what are the total number of previous choices are there? 4. So that's the same thing, right? K minus 1 into total previous. So K minus 1, what are there? Because one choice I'm already using the first one. So how many left? K minus 1. K minus 1 into the total number of choices that are there for the previous one. That is 4. So 3 into 4, that's 12. That same thing that we have got here, right? The same possibilities. Now let us assume we are doing it for third one. Okay. So now I'll just write these things here. For this, the same is 4, and the different is 12. Okay, now if I join the third section, then you people will get a better understanding. So I'll just erase this, and I'll even erase this part. Okay, fine. Just give me a moment. Okay, so I've just erased it, and okay. And what about this total? So this total would be equal to 16. Okay, total would be equal to 16. Now let us assume I'm joining a third section. Okay, I'm joining the third section. Now I wanted to, again, there are two options here. I wanted to paint it differently, or I wanted to paint it same. Okay, I wanted to paint it differently, I wanted to paint it same. Or let us first write same, so that you'll be getting a better clarity. Same and then different. So now I wanted to paint it same. So will I take the case of same of the previous? No. If I take the same of the previous, so first one I'm painting it as blue, second one I'll be painting it as blue, and that is counted in the same section. And will I consider it? If we consider it, then I need to paint blue here as well, and that violates the option. That violates the restriction that has been given. So that is the only reason I'll be not be taking for the same of present. For evaluating the cases for the present, like the for present same, I'll not be taking the previous same. I'll be taking the previous different, right? That's the relation we have written before. Previous of different, or yeah, this one different of previous, right? This is what I've written, different of previous, because I cannot take this same thing of the previous sections. If I take that, our conditions being violated. That's what we need to make sure, right? So I hope you people understand why are we taking the different of previous. If we take the different of previous, then only we can make sure we are not repeating the color. So blue and blue, if I've taken, I must not take this once again. This is like same category, so I shouldn't take it. I should take a different category, so that like if this is like instead of blue, if this is red, I can take this, right? I can take this, so that I can paint this to be red. That's completely fine, because red consecutive is fine. It's blue is not fine. That is not acceptable. Okay, so we must take the cases in the previous that are different. Okay, that are different, that only I can take it, and I can put the same color to my last section. Okay, I hope you people are getting. And what about the different part, different thing? So whatever the total possibilities that you had, I can replicate, I can use the same things, right? So k minus 1 into the different of, sorry, total of previous. Why? Because I wanted to make it different. I wanted to make it different. So whatever the available choices that have been used, in that I'll be subtracting one, because one has been already used. So I'll be using k minus 1. So for example, we have listed down all the options, right? Before, what are the options that we're having in the second one? So they were like BB, GG, RR, YY, and this was the same category for this. And what was the different category? This was like a BG, BR, BY, GB, GR, GY, and what is the other thing? RB, RG, RY, and YB, YG, YY. Oh, sorry, YR, right? YG, YB, YR. Now, if you are trying to paint something different to the third color, what are the available choices? Now I can easily put, like I'll be using the white color now. I can put something like k minus 1 options are there. K minus 1 options are there. So out of 4 colors, I'll be using any three colors. So I can, if I'm trying to paint in for this particular thing, I can put BB, G, BB, R, BBY, right? BBY. And what if for this GG? So GG, like different color, GGR, GGY, GGB, right? And for RR, RRB, RRY, and RRG, right? And for YY, what is there for YY? So YYR, YYB, and YYG. So that is the reason when we are multiplying by k minus 1 into the total of previous. So total of previous is same plus different of previous, right? So it is basically k minus 1 of same of previous plus different of previous. So that is k minus 1 times same of previous plus k minus 1 times k minus 1 times different of previous. So what is k minus 1? 4. Sorry, k minus 1 is 3. What is same of previous? 4. So that is equal to 12. So did we get 12 choices or not? Count. So this is 3, 3, 3, 3. How many are there? 12. So we have got the same 12 here, right? I hope you people are understanding. So we are trying to merge k minus 1 different available options to each of the different things. Okay. Now similarly, I will multiply k minus 1 with different of previous. What are the different of minus? 12 are there. Into k minus 1, that is 3. That's equal to 36. So if we can just join each and every different possibilities. So from this, how many possibilities I would get? From this, I would be getting 3. I would be getting 3 because BG. So BG, B I can put BG, Y I can put BG, R I can put, because I'm looking out for different possibilities. So I cannot put G here. I'm looking out for different. Okay. So I can put BGB, BGY, BGR. So for this 3, this is done for BG. Okay. Now we will come for BR. You will again evaluate. They'll be getting 3 options. So totally 12 things are there. So 12 into 3, 36. So the same thing applies here. The same logic we are putting it in the formula, isn't it? If you do it in the manually, if you try doing it in manually, you'll understand what is the relation between the present work and the future work, right? So I hope you people understood. So whenever you're trying to calculate the present same, okay, whenever you're trying to calculate the present same, just take the different of the previous. And when you're trying to calculate the presents different colors, so you can multiply k minus 1 with the total possibilities that you had for the previous. That's it. So you can just keep on doing till when you reach the value of n. So till you reach n sections, right? So that's the only logic. So instead of taking any extra space, we are not taking any extra space. We are just manipulating the same and different, right? I hope you people understood. So it's the same code. If you're facing any doubts or difficulties, just do this manual dry run. Okay, take a paper, color it first. I mean, colors not, you need not write, take the paint and do it. Just represent it with some color and put in another section now. Try doing it and put in another section now. Try doing it. You'll understand, right? You can get all the options available. Take limited options like k equal to 4 or k equal to 3, and then you can get a better clarity, right? So I hope you people understood. Everything is clearly, I've explained it from the grassroots level. What is the case of same, what is the case of different, how do you have a relation between these two, etc. and etc. So now let us code it up. So first one, take long total possible ways to be k for the very first section, right? For the very first section, and different is k, and same is 0 as discussed, right? Same is 0, and take mod to be 1e9 plus 7. Now start from int I equal to 2, or section int section equal to 2, sections, okay, sections equal to 2 till sections less than or equal to n, sections plus plus. Okay, sections plus plus. So what is the presents? Okay, now we are evaluating your present same. So present same is whatever the different that you had, that only will be there. And what will be the different? Your different would be whatever things that you have taken in the total previously, that will be multiplying with k minus 1. So k minus 1. So k minus 1, first you take mod with it, and then take multiply with the total that you had. Total, again take mod, and the whole mod. Okay, whole mod. Okay, this is done, and same is done. Different is done. Okay, what would be your look, your total now? Total is equal to same plus different whole mod. Okay, same plus different whole mod, and return the total. Okay, return the total. I hope you people understood what did we actually try to do. First one, initially we had total possibilities are k, and different possibilities also k, because there's nothing else to compare or add. So same would be 0. So mod is 29 plus 7, and for in sections equal to, now we are joining another section. So once you join for your present section, the same number of possibilities for same is equal to the different of the previous. So that's what we have written, same equal to the difference, and difference for the difference purpose. Now what is your difference? Different possibilities, you just multiply k minus 1 into the total possibilities that you had so far. So that's the reason we are multiplied, and we are taking a mod so that it is in the range. And finally, what is the total? You just add them up. So this total will be useful when you're evaluating for the next sections. Okay, so I hope you people understood. Let us first try to do a sample run and check. Okay, it's working fine, and now let us submit. Okay, so it worked perfectly. I hope you people understood. So what is the approach and all. So if in case there are any doubts, please feel free to comment in the comment section. I'll revert back to you people, and I will even explain you all stuff if there is any doubt. And for your information, the codes in Java, C++, Python are there in the description. Please go through them. And to be honest, it's very good question, because I had actually learned that algorithm. I was able to solve it at a very first go. I actually had put some efforts in learning that algorithm as well, because it's not very easy to come up with such an intuition. It's because it's a recursion thing. We need to try doing things. We need to find a relation. I thought of using a 2TDP, all this stuff. I did a lot of efforts before understanding it, before going to that algorithm. But after that, once I actually understood that algorithm, it's like, yes, we can develop an intuition starting from the first section. So first section, we have evaluated about what's the total number of same and different possibilities, and then now we are adding in another section. What are the things that you're going to look for? And when you're trying to have the third section, what are the things that you're going to look for, and formulate your same and different accordingly. And finally, your total number of combinations would be the same plus different, and that will be useful to evaluate the next section. Okay, your present total will be useful for the next section as well, because you'll multiply that present total with k minus 1 to evaluate the next section different case, right? So that's very important. So once we do that for till n, we are done. So that's the reason I told you this problem is pretty similar to the yesterday's problem of the day. Yesterday's problem of the day was also the same thing. We are like inserting zeros and ones. We are making sure two ones are not consecutive, and that's the same thing, right? So we are following a pattern for the first one, and we are developing that pattern till n. That's it. So we are just extending the pattern. So I hope you people understood this. So thank you for watching, guys. Stay tuned.